Hello everyone. Today my presentation is just about not just a classification model, but a cost-aware medical prediction system designed specifically for healthcare risk assessment rather than simply training a model and reporting accuracy. This pipeline is structured around data reliability, feature optimization, and balance handling, ensemble learning, and cost-sensitive evaluation. Every design choices reflects and the reliability that in medical prediction mistakes carry asymmetrics in consequences. I begin with data integrity just from here. The first step in my pipeline is to remove duplicate records from the training set. This is essential because duplicate sample can cause hidden data leakage. If the same patient appears in both training and validation splits, the model will memorize its patterns rather than generalize. This leads to inflated validation performance and unreliable results. In healthcare contexts, such as artificial performance is dangerous by eliminating duplicates. I ensure that evaluation metrics reflect true predictive ability. Next, I generated a correlation matrix and I think it's over here, to analyze relationship among features. Medical data often contain overlapping health indicators that measure related sociology conditions. Fitting highly correlated variables directly into a model can introduce redundancy, amplify noise, and reduce interpretability. The correlation analysis provides structure, insight, and informs subsequent feature engineering and dimensionality decision. This step ensures that modeling is guided by data structure rather than blind automation. I then apply both feature expansion and dimensionally reduction. First, I constructed Morbo index by combining high blood pressure, high uh, cholesterol, and stroke indicators. Chronic conditions often cluster and risk accumulations rather than acute active independability. By aggregating these variabilities, I enable medical reasons into a feature space. I also introduce an integration feature between age and BMI to capture non-linear risk growth patterns. After expanding the feature space, I apply PCA and extract thread pipeline comments. This component summarizes the uh summarizes the interaction feature between age and BMI. Actually, this combination of structure expansion, control compression, stability, the feature space. Class imbalance is another crucial issue. In diabetes prediction, positive cases are significantly fewer than negative ones. If imbalance is ignored, the model may achieve high accuracy by predicting the majority class. To prevent this, I adjust class weights into XGBoost and light JBM, increasing the penalty for misclassifying positive cases. I intentionally prioritize recall over raw accuracy because missing a diabetic patient is far more closely than reducing additional screening. The modeling architecture is built as a ensembling, combining XGBoost and Light GBM, a neural network using soft voting. A tree-based models handle nonlinear tabular integrations effectively, while the neural network captures combination nonlinear relationships differently. Because these modes learn in different ways, their error or loss correlated soft voting allows probability confidence to influence final predictions, producing a more robust decision system. Evaluating its explicability, cost sensitive. Instead of focusing solely on accuracy, I analyze the confusion matrix and define a weighted cost function where false negatives carry 5 times the penalty of false positive. In healthcare, a false negative represents a misdiagnosis which can delay treatment and worsen outcomes. Therefore, recall an F1 score are prioritized to align the mode with cynical priorities rather than just sustainable metrics. Finally, although finally the system is engineered rather than improvised. It controls for data leakage, amounts for structural redundancy, integrates dominant form feature design, cracks, class imbalance, leverage heterogeneous enable learning, and evaluates performance through mathematical cost lines. The object is not simply to predict, but predict responsibility.